So we are going into comparing two independent population proportions instead of independent population means. All right, we're going to be talking about two population proportions. We have a few different requirements. Same requirement that they have to be independent, fully separated, and simple random samples. The second is very similar to when we did proportions in our chapter 9 section. We talked about n times p being greater than 5, greater than or equal to 5, and n times q being greater than or equal to 5. That's exactly what this is. There's at least 5 successes. That means n times p is greater than or equal to 5. There's at least 5 failures. That means n times q is greater than or equal to 5. And this growing literature just means that it has changed over the years. So currently, we keep it at the population needing to be 10 or 20 times the size of the sample. This isn't something that we deal with very often. Usually when we're talking about populations, they're very large in general, but if we had some kind of circumstance where we were dealing with our population being some super rare type of butterfly or an animal that's almost extinct or something where our population itself was really, really tiny, you need to make sure your sample is proportionate. All right, you're not essentially oversampling where you've collected so much of the population that you almost have the entire population at that point. Once again, does not happen super often, but it's just something to be aware of and conscious of as we go through this process. All right, the difference of two proportions follows an approximately normal distribution, just like our proportion followed an approximately normal distribution. Generally, our null hypothesis for proportions is going to be that we think they are equal, meaning that that null hypothesis is going to be that the proportion of A is equal to the proportion of B. Sure, it could be thought in the past that it was more than, greater than or equal to, or less than or equal to, right? This is just kind of a general rule of thumb, more so what you see in a lot of examples. It's not usually going to state what you think it was originally, but we just kind of assume, you know, for proportions that, geez, I'm not going to try to come up with an example off the top of my head. We think that they're equal generally. All right, the null hypothesis, our preconceived notion is that their proportions are equal, and their alternative is going to fill in what we're trying to show, our claim. All right, let's look at actually, we'll start a new video to look at our first example.